Good morning, students. It's your first lecture. I teach you physics. The first lesson of physics is force, work, energy, and power. And in chapter first, we contain first units turning effect of the force and the equilibrium. The first turning effect of the force, the turning effect produced by the force. Force means effort. Turning effort produced by the force. The moment of force. For moment of force also called torque, represented by torque. The represented by tau. Tau. The tau is equal to F into D. F means force into D. The moment of force also means is the torque. It is the depend upon the force and perpendicular distance. It depends upon the force and perpendicular of the distance. The SI unit of torque is force represented by Newton and distance represented by meter. The SI unit of moment of force or torque is Newton and meter. One question is produced from there. The relation between the SI unit and CGS unit of moment of force or tau. Relationship between the 1 Newton is equal to 1 meter, 1 Newton is equal to 10 to power 5 dyne, and 1 meter is equal to 10 to 2 power 2 centimeter. Now 10 to power 7 dyne into centimeter. Relationship between SI and CGS unit of moment of force torque is 10 to power 7 dyne centimeter. SI and CGS units of torque. Relationship between SI and CGS unit of torque is Newton meter 10 to power 7 dyne per centimeter. 1 Newton is equal to 10 to power 5 dyne and 1 meter is equal to 10 to power 2 centimeter. Now the second motion. The two types of motion in present in physics. Firstly in translatory motion and secondly in the rotatory motion. What is the translatory motion? The motion represents a straight path. The motion is between the all part of moving both uniformly along the straight line is called the translatory motion. Example, man running a bullet fire from the gun. Also in straight line motion called translatory motion. Example, a bullet fired by the gun. Secondly, rotatory motion. Rotatory motion means that motion or all particle of moving body follow a circular path with the respect of fixed axis like ceiling fan. The ceiling fan, all particle of the moving body follow a circular path with that is fixed axis. Fixed axis. Now we couple the two equal and opposite parallel forces acting along a different line on the body that constitute a couple. Like when a rod when a force acting in a south direction 10 newtons and same magnitude of 10 newtons in north direction. Same magnitude but opposite in direction called the couple. What is the center of gravity? What is the center of gravity? Center of gravity. What is the center of gravity? Is the point through which in the resultant of weight of all the particle of the body act called is the center of gravity. What is the center of gravity? The point through which is the resultant of the weight of all particle of body is act is the called in center of particle. The simple way we say that the center of gravity, which part of body where all resultant force act. In simple word, we say that the center of gravity is which part of body where all the resultant force act. That is called the center of gravity in their bodies. Some numerical problems. The principle of movement. Asli principle of movement. The principle of movement, that is called the force act on clockwise body equal to anti-clockwise bodies. The principle of movement says that the clockwise force movement equal to anti-clockwise. In other words, we just said that the resultant force equal to zero, called the movement, the principle of movement in equilibrium. Okay. Firstly, some example. The meter scale, 100 meter scale, the fulcrum on 50 centimeter is load a force 40 Newton on 30 centimeter A represented, and another 80 centimeter 20 Newton represented. We find that the 20 Newton force, which point stated the meter scale is balanced. This point the balance the seesaw meter scale balance. Now the rule of principle of movement. The clockwise movement is equal to anti-clockwise movement equal. Now the movement is the definition of movement is that tau is equal to F into D, force into distance from the fulcrum perpendicular. D is the distance between from the fulcrum to the force. 140 into 20 is equal to 20 into D. 220 से 20 can cancel to 20 to 20. Now 40 centimeter distance. Hence the 20 Newton of force B is acting from the 50 plus 40 90 centimeter mark. If 20 Newton force acting on 90 centimeter mark, then seesaw and or meter scale is balancing. Other question? calculate resultant moment of force. The sum of all clockwise movement. Calculate the resultant moment of force. Firstly, we found the clockwise movement. Firstly, the distance of the movement is the represented tau is equal to F into D. Force into distance. First, clockwise 20 into 5 plus another second case the 40 Newton into 3 because the force in the clockwise. The moment of 40 Newton is clockwise. Third, 10 Newton. 10 Newton is 40 into 3 plus 10 into 2. The total 100 plus 120 plus 20 is equal to 240 Newtons. Anti-clockwise movement. Only one force of 100 Newton is the anti-clockwise. Then 400 into 4 into 400 Newton into meter. 1000 Newton force acting on the center. So resultant movement is 0. Now resultant torque is 400 minus 240 is equal to 160 Newton meter. That is answer. Now first 20 Newton, 10 Newton and 40 Newton, three forces are acting in the clockwise and 100 Newton force the move in anti-clockwise. The clockwise movement is 20 into 5 and 4 into 3 and 2 into 3. Three forces are acting on the clockwise force. The resultant movement of clockwise to 14 Newton meter, anti-clockwise 400 Newton. 1000 Newton force acting on the center. So the moment of 1000 Newton is 0. Now the resultant torque 400 minus 240 clockwise minus anti-clockwise, which is more than subtracted. 400 minus 200, 160 Newton meter. Thank you.